Not AD. What is the length of BC? We have a circle here with a radius of square root of 50. Lengths that are given to us, DB is 2 and BA is 6. They create a right angle here, and that connects B to C, which is the missing length we want to find. Pause this video, see if you can figure it out, but as always, I'm going to dive in and show you a way to solve this problem. First things first is we can draw more lines. I'm going to start from C, and I'm going to draw a line perpendicular to BA across from our center of the circle. Right there. Draw a little line. It's perpendicular right there. And I label this point E. Let's give EC a length of X. So EC equals X, and while we're at it, let's call EB Y. From there, I'm also going to connect AC. Remember, AC, that length is also the radius, so that length is square root of 50. What is the length of EA? Well, if BA is 6 and BE is Y, we can state that EA, that length, is 6 minus the length of Y. From here, we have, well, 6 minus Y. Pythagorean theorem can be used on this triangle. A squared plus B squared equals C squared. X squared plus a 6 minus Y squared is equal to the square root of 50 squared. All right, that's one formula right here. Let's see if we can create another triangle. I am going to now draw an extension of the line DB. DB, I'm going to extend over until we're perpendicular with the radius, and I'm going to go down here. So I'm extending line DB, let's call this point F here. It's a right angle as designed and goes right to our radius. Well, what do we know about some of these missing sides? FC also has a length of Y, right here, and BF has a length of X, BF. Because we drew a rectangle now inside, what we also know is the length of DC. Kind of zoom in here, take your time. DC is another radius. So DC, I'll label it again here. DC is our radius, again, which is equal to square root of 50. So we're going to use Pythagorean theorem to find our missing lengths here. A squared plus B squared equals C squared. Well, Y squared plus this length of DF, which is 2 plus X, all squared, is equal to our hypotenuse squared, which is the square root of 50 squared. We now have our second equation. Both of these equations have an equal to square root of 50 squared, which is just 50. But since they're both equal to the same number, we can set them equal to each other. First equation, x squared plus 6 minus y all squared equals the second equation, y squared plus a 2 plus x all squared. Let's simplify this out. X squared comes down, multiply this part out. 6 squared is a 36. Minus is going to be 6y minus 6y minus 12y plus a y squared. Negative y times negative y y squared. Equals y squared comes down here. Same idea, plus 2 times 2 is a 4. 2x plus 2x is a 4x plus x squared. Now luckily, a lot of things cancel. X squareds cancel here, y squares cancel, and I bring all of our variables to one side and our numbers to the other. So I'm going to subtract a 4 here to both sides, and I'm going to add a 12y to both sides. What I'm left with is 36 minus a 4, which is a 32, is equal to 4x plus a 12y. Now all of these are divisible by 4. So I divide 4 across the board to simplify this up a little bit. 32 divided by 4 is an 8, equals 4x divided by 4 is a 1x, and 12y divided by 4 is a 3y. So I have 8 equals x plus 3y. This linear equation ends up being the final piece of the puzzle. So I'm going to take 8 equals x plus 3y and kind of guess at what x and y values make this work, okay? So we have, if I pick an x and y value here, if I pick an x value of 5 and a y value of 1, this is still a true equation. 8 does equal 5 plus 3 times a 1. So I'm going to test that and see if it's true for both of my equations here. I'm going to plug it in, and we should get 50 for each one. X is 5, first one 5 squared, plus a 6 minus y1 all squared. 5 squared is a 25, plus 6 minus 1 is a 5 all squared, 25. 25 is a 50. We're good. Let's try it with our second equation. 1 in for y, 1 squared, plus a 2 plus a 5 squared. 1 squared is 1, plus 2 plus 5 is a 7 squared is a 49, and we have 50 as well. And so 5 and 1 for our x and y work for both equations that we created and where we got through here. So we're going to use that information to find the length of BC. Now, BC is its own hypotenuse of a small triangle, BFC. Pythagorean theorem has been our best friend this whole time, and one more time he will be called upon. X, 5 squared, plus y, 1 squared, is equal to our BC length squared, our hypotenuse squared. 5 squared, 25, plus 1 squared is 1, equals BC squared. 26 equals BC squared. And so the length of BC is equal to the square root of 26 when we square root both sides. So our BC length is the square root of 26. And if you want it as the approximate decimal, I have a 5.09902. But I prefer the square root of 26. Was this the answer that you got? If so, way to go. If you didn't, but you learned something, that's the whole goal here. As always, thanks for watching.